Okay guys, quick little video here on distance time graphs. So you guys are going to play around with an emulator on your computers and create these things. What you're looking at here is, or the reason we do this is because it's a real life use of linear functions or real life use of lines. And what you think of is somebody in a house, okay, there's my great little house here, and a man walking here from his house or towards his house. So we always talk about the house and school, for example. So school's over here, that sort of thing. And what he does is he starts to walk, and as he walks, time passes. Okay, and as he walks away from his house, his distance from his house. So this is his house, really. Okay, or 0, and then this is a school or a certain distance. But a lot of times we don't have numbers here. It's just general distance. So distance away from something. So as he walks slowly away from his house, he gets further and further away, and time passes. If he speeds up, then we talk about what happens to the slope of the line. It will become greater, and as he speeds up, he gets faster and faster and faster, and distance over time, the distance to time ratio gets higher. Okay, so we have a increased slope. If he was to stop, his distance wouldn't change. He'd still be, so if he walks and he's here, and then he runs for a bit, and he gets all the way to where he is now, and he stops for a bit, well, his distance doesn't change, but his time won't. Okay, and he waits and he waits and he waits and he waits and he's still at the same spot. And then if he keeps going to school, maybe a little bit slower than maybe he jogs now, walk, run, jog, then that's the sort of thing, and he gets to school. Okay, so those are distance time graphs. Some just little things to bring up. If he's walking to school and then he stops and he's walking to school and then he stops and he goes, oh, I forgot something, and he wants to come back home, we're not going to do this, right? Because this would mean that he's going back in time. So instead of doing that, let me get rid of that. His distance will decrease, right? So his distance will come down, but time will not decrease. Okay, so this is called a function because as you read this line, it does not go back on itself. And most relations in real life are actually functions. The ones we care about are functions. Okay, and that means that they don't come back on themselves. They don't loop back. You don't have a shape like this or a shape like this or a shape like this. Okay, because time always moves from left to right. Time always moves from a negative to positive point of view. Well, the other thing I'd mention is if you see him moving, and this is not part of this course because you'll see in a second, it doesn't make a line. You see him moving, and then he speeds up, and not that he gets faster. So here he's walking, then he runs. He walks at a constant pace, then he runs at a constant pace. But if he actually speeds up, so let's say he takes a little break, and now he speeds up, he will get faster and faster and faster, and then you'll actually see a curve. Okay, sorry, it won't come all the way back. I should draw it. Be careful. It won't come back on itself, but it will speed up like this, and this is called acceleration. And then what you can do then is, and this will be on the simulator. You'll notice the second part of the simulator that you'll play around with. I'll have a velocity time graph. Okay, and a velocity time graph. This then will look like this. It'll be a straight line. So consistent increased velocity is acceleration. And so the change in distance over time, so delta d over delta t, that is velocity. Okay, so that's what we're looking at. But if you change your velocity over time, so the change in distance over time, that's acceleration. Okay, so that's physics stuff. And you may see that when you're playing around with your simulator. That's what I'm telling you. Anytime you see a curved line, that's some sort of acceleration. Okay, you're getting faster and faster as you move on. Okay, hopefully that made sense. And take care.